Dear students, with best wishes to you all, I will establish the relations among elastic constants. The elastic constants are Young's modulus Y, bulk modulus K, and modulus of rigidity and Poisson's ratio sigma. Modulus of rigidity small n, Young's modulus, it is equal to longitudinal stress F by A divided by longitudinal strain small l by capital L. Bulk modulus volume stress F by A divided by volume strain small v divided by capital V. Modulus of rigidity n equal to shear stress divided by shear stress F by A divided by shear strain theta. Poisson's ratio sigma equal to lateral strain divided by longitudinal strain. Let us take a solid unit cube of length 1 meter. Unit cube has been taken to establish the relations in an easy way. It is placed in a three-dimensional Cartesian coordinate frame in such a way that its three adjacent edges lie on the coordinate axis as shown in figure. If we pull it along x-axis with a force P, then P will be the longitudinal stress. It will produce a longitudinal strain P by Y along x-axis as Y equal to longitudinal stress P divided by longitudinal strain. Therefore, longitudinal strain equal to P by Y. Along with this longitudinal strain, two contractional strains minus sigma P by Y minus sigma P by Y are observed along the other two axes Y and Z. As sigma equal to lateral strain divided by longitudinal strain, that is longitudinal strain is P by Y. Therefore, lateral strain equal to sigma P by Y. A similar job is performed in other two axes and the results are shown in a tabular form. Look at the table. The stresses along x-axis, y-axis and z-axis and strains produced along x-axis, y-axis and z-axis. First, the stress P is along x-axis and no forces act on other two axes. Then the longitudinal strain along x-axis is P by Y and there will be a contraction in y and z direction. Such a contraction is minus sigma p by y, and another one is minus sigma p by y along y and z axis. Similarly, 0 p 0, it makes p by y longitudinal strain along y-axis and other two axes minus sigma p by y. Third one, 0 0 p makes a longitudinal strain p by y along z-axis and in other two axes minus sigma p by y minus sigma p by y. If we pull the cube in x, y and z directions simultaneously, then a volume stress P is obtained. Volume stress will be P. The longitudinal strain in each direction will be P by y 1 minus 2 sigma. Therefore, the bulk modulus K equal to volume stress P divided by volume strain. Volume strain is 3 times the longitudinal strain. Therefore, volume strain will be 3p by y 1 minus 2 sigma. That is y divided by 3 into 1 minus 2 sigma. Therefore, y equal to 3k 1 minus 2 sigma. Now we apply an extensional force along x-axis and a contractional force along y-axis, negative y-axis, that is minus p. It is shown in table, in this table, extensional force P along x-axis, then the strain will be along x-axis P by y, and other two axes minus sigma P by y, minus sigma P by y. And contractional force minus P will make a negative longitudinal strain along y-axis minus P by y and plus sigma P by y plus sigma P by y in other two axes. It makes a shear stress P. An extensional strain P by y 1 plus sigma and a perpendicular contractional strain minus P by y 1 plus sigma. Therefore, the shear strain will be twice P by y 1 plus sigma, and the modulus of rigidity N equal to shear stress P divided by shear strain twice P by y 1 plus sigma, that is y by 2 1 plus sigma. Therefore, y equal to twice n 1 plus sigma. This is the second relation. From equation 2, we may write 1 plus sigma equal to y divided by 2n. Therefore, sigma equal to y by 2n minus 1. From the first equation, we have y equal to thrice k 1 minus 2 sigma. Putting the value of sigma in this equation, we have 3k 1 minus 2 y by 2n minus 1. That is thrice k 1 minus y by n plus 2, that is 3k 3 minus y by n. That is 9k minus 3ky divided by n. Multiplying the equation by n, we have yn equal to 9kn minus thrice ky. Therefore, y 3k plus n equal to 9kn, or y equal to 9kn divided by 3k plus n. This is the third relation. Thank you.